All right, welcome back. We're going to start off on page 210. I went ahead and printed out a new copy because I need a lot of room to do this. And so we're going to start with logarithms that are natural base of e. There's a definition here. So the logarithms with a base of e are called natural logs. And log base e is written as ln. I believe it's Latin or maybe French or Italian, don't quote me. But it's logarithmic natural. So log base e of x is written as ln x. All right, so this is the definition of a natural log right here. Okay, so anytime you have a log that's a base of e on your calculator, you're actually not going to use log, you're going to use natural log. All right, let's go ahead and flip it back over because we're going to be using, it says use the functions from item 2. Item 2 was right here, right, item 2. Complete the expression for each composition. So go back to item 2, and what we need to do is we need to rewrite these in the other forms that we have. So for example, I have x equals x equals x equals. I'm going to change these into something where I get y equals y equals y equals. So on this one, it's an exponential function. So the way that I changed this into a log function, remember it's log of the base, so log base 5 of the answer, x, equals our exponent y. So log base 5 of x equals y. Here, going the other direction is a little easier. We go 2 to the x equals y, so 2 to the x equals y, and here e to the x equals y, so e to the x equals y. All right, we're going to use these functions. These are our g of x, so let's go ahead and write those down. G of x is, on this one, it's log base 5 of x. On the next one, there's actually a typo here. This should be a 2, guys, right here. So g of x, from the previous page, g of x is 2 to the x. And on this one, the last one, C, f of x is e to the x. G of x is e to the x. All right. I actually think they have a typo there as well. Yes, they do. Look, they have their f of x written incorrectly. So another typo, we need to rewrite this. F of x was log base e of x. We might just skip this one then because it's I think there's a typo, but well, we'll see. Okay. All right, so on the first one, they want us to compose, well, on these, they want us to compose our functions, composition of functions. Just to remind you, you take the outside function first, which is f. F is 5 to the x. So you take the outside function, 5 to the x. And actually, I was just doing this for math too, so I'll just show you the directions so I don't have to rewrite them. So please write your directions down if you've forgotten how to compose functions. Right? So this was for math too. Write the outside function, leaving an opening wherever you have an x. Substitute substitute inside function into the opening and then simplify. Okay, so if you've forgotten the directions for composing functions, you actually did learn them in math too, and we did them earlier this year, but there they are. So I'm going to take my outside function f, which is 5 to the x, and I'm going to insert my inside function, which is log base 5 of x. Now, we did this in class a little bit, but something you have to know, right, is about inverse functions. About exponential functions is we know that exponentials and logs are inverses. So those actually just cancel out, guys, and we're left with x. All right, so right here, I'm going to do it right here, 5, and then to the log base 5 of x. And I said that logs and exponentials are inverses, so they cancel out. And there we go. All right, we're going to do it the opposite direction, g of f of x. So we're going to take the outside function g, which is this one, log base 5 of x, and then we insert, right, the inside function, which is 5 to the x. And then what we said just a second ago is that logs and exponentials are inverses, so they cancel out. Log base 5 of 5, I just get x. Oh, you could pop this out using the quotient rule, or I mean the product rule. Sorry, I'll get it right in a second. The power rule, but you can just drop it straight down. It's fine. All right, let's do the second one. B, f of g of x. So we're going to write log base 2. Remember to fix that. And then 2 to the x. And as you can see, just like here, the log and the base 2 of 2 cancel out, and we're left with x. The same thing here, we're going to do g first, so 2 to the x power, and we're going to plug in log 2x, and exponentials and logs are inverses, so they cancel out. And finally, I think we're going to skip this guy, but you get the idea that logs and exponential functions are inverses, and you can verify that using compositions of functions. Okay, it says examine the function f of x equals e to the x and its inverse g of x equals natural log x. Complete the table of data for f of x equals e to the x, then use those data to complete the data for this function. So remember that our domain will become our range. So I'm going to go ahead and put those in right now, -2, -1, 0, 1, and 2. And then you have to use a calculator to evaluate these, right? E to the any power. So on your calculator, it's generally behind the natural log function. So second natural log is going to give you e. E to the -2 is 0.135, so 0.135. E to the -1 is 0.36. I'll round that to an 8. Anything to the 0 power is 1. E to the first, so this is the actual value of e. I think earlier I said 2.18. It's 2.718. My apologies. And then e to the e to the second is 7.389. All right, we're going to remember our domain and range switch. So that becomes our domain. This is 0.135, 0.368, 1, 2.718, and 7.389. All right, you can't get those values without using the ideas of inverse functions. Okay, flipping it over to the next page, it says complete these inverse properties of logarithms. Assume that b is greater than 0 and it's not equal to 1. And so these inverse properties, what they want you to understand again is that inverse that a log and of a base with raised to this same base. Sorry, let me say this again. When you have a base and you raise the exponent to log of the same base, they cancel. So those will cancel out and you end up with just x. And similarly, if you have a log with the same base and the solution is that base, they cancel and you just get x. So it says simplify each expression. Go ahead and try these. You should pause the video here. I'm going to do them off to the side. So 6 to the log with the same base of 6 is x. We said that if you raise a base to the log of that base, they cancel and you just get x. Same thing here, log with the same base, 3 to the x, these cancel and you just get x. Are you seeing the pattern here, guys? 2 to the log 2, you're going to get x. The base here is 10 if it's not written, so log base 10, 10 to the x is x. Natural log, remember the base of natural log is e, so e and natural log cancel and you get x, and e and natural log cancel and you get x. All right, those were pretty easy, I think. It says describe the process you use to find the inverse function g of x if f of x equals 7x plus 8. Okay, so this is kind of a review. Describe the process. I'm going to say it for the 8 millionth time. Number 1, rewrite y equals f of x. Number 2, switch x with y. And number 3, solve for y. All right. For number 9, construct viable arguments. Look at the graph in item 1. What can you conclude about the line of symmetry for a function and its inverse? The line of symmetry is always the line y equals x. We actually already answered that. And then answer each of the following as true or false. So answer each of the following as true or false. Please go ahead and read those really quickly. I'm looking for a page. Okay, I found it. Okay, so the first one, it says, answer the following is true or false. The -1 in function notation means 1 over f. That is false, guys. It means that it's the inverse. So explain. No, f inverse x means that f inverse is the inverse of f. Okay. If exponential functions are the inverse of logarithmic functions, true or false, guys? And that guy is true. No reason to explain. If it's true, you know, that's just the definition of an inverse and a log. And if the inverse is a function, then the original must be a function. So that goes back to last semester. If the inverse is a function, then the original must be a function. That's false. The original may not necessarily be an inverse. Or sorry, the original may not necessarily have been a function. I'm trying to think of an example where that would happen. Oh, I can think of one example, a horizontal line. So if the inverse function is a horizontal line, then the original function was a vertical line. They would be symmetric across y equals x, and this is not a function. So I'm just giving you an example. So not necessarily was the original a function. All right, guys, that's all the notes. You're going to be working on these in class on Monday. So if you want to get a jump start on them, they look pretty darn easy to me. And I will see you Monday. Have a great weekend.